Welcome to chemistry at Hananiga High School. Today we'll be looking at our last nomenclature chapter. And in this chapter, we'll be talking about other substances. Last time we got into ionic compounds, and ionic compounds are nice because they're purely driven by charge. So if you know the charge of the ions, you can figure out the formula and you can figure out the name. But there's two other types of substances we also want to be able to name, and those would be simple molecular substances and then also elemental substances. So that's what we're going to be looking at in this chapter is naming those two types of substances. Now, substances themselves are either elements or compounds. And one of the things you'll do in the homework assignment related to this is trying to differentiate between the two, which is really straightforward, and you probably already know how to do it. Now, from the compound point of view, we've got two different types of compounds we want to be able to name and find the formula of. And those are simple binary molecular compounds and then ionic compounds. Well, we've already done the ionic compounds, so that one's out of the way. Remember, ionic compounds always started with a cation, which was either a metal or ammonium. So if you ever start with either of those two things, then you know it's going to be an ionic compound. But the type of molecule that we're going to learn to name is a binary molecular compound, which really means it's just got two elements in it. And since it's molecular and it's going to be sharing electrons rather than transferring electrons like ions do, it's going to be a binary molecular compound, which means a two non-metal compound. Now, on the other side, we've got elements. And one of the things about elements from the periodic table is you may not realize, but it's something you've seen evidence of. In biology, when you talked about oxygen and they ever put its formula, they didn't write O, they wrote O2. Well, there's other substances that also form what are called diatomic molecules that are elemental. So when you have an elemental substance, it's either going to be atomic, it exists as single atoms, or it's actually two atoms fused together to make a simple molecule of the element. And it's really about stability. If it can be stable enough as an atom to exist, then it will. If it can't be stable enough as a single atom, then two atoms of the element will get together, share electrons to form a stable substance. So those are really the situations we're going to look at. From the elemental substance category, we've got atoms and diatomic molecules. And then from the compounds, we are looking at binary molecular compounds. Now, how do you tell if a substance is elemental? Well, honestly, look to see what it's got. If it only contains one element, then it's an elemental substance. So elemental substances are literally just a single element. They're not a compound. So more than one element compound, only one element, it's an elemental substance. And the nice thing about elemental substances is they're fairly straightforward. And that's really what we're looking at in this first set here. We'll get into molecules next. But with atomic elemental substances, what you have is literally an atom of that element existing. And most of the elements in the periodic table are monatomic in their elemental form, which means they're one atom. Carbon is just C atoms. Gold is AU atom. Silver is AG atoms. Sodium is Na atoms. Most of the elements in the periodic table, they exist in that form as a single atom in their elemental form. But there are 7 atoms that aren't stable enough when they're just plain old atoms. And they actually form molecules of the element. In other words, 2 atoms are going to get together and share electrons, and they're doing it just like we talked about when we talked about transferring electrons. They need to get their full octet to become stable. Well, there's 7 elemental substances that actually do this and form what's called a diatomic molecule. So what are the diatomic molecules? Well, first, they're 2 atom molecules of the same element. So it has to be the same element, and it's always going to be 2 of them. Like you saw, O2 was the formula for oxygen that you're inhaling. There are 6 other elements that do the exact same thing. Now, from a formula point of view, all you really do to write the formula is you're going to put 2 of them together. So it's going to have a subscript of 2. Now, these are the 7. Hydrogen, oxygen, nitrogen, fluorine, chlorine, bromine, and iodine are the 7 diatomic elemental substances. So how do you remember them? Because when you look at the periodic table, there's no indication on the periodic table to help you know these are the diatomic ones. Well, I've seen 3 different ways that can help you remember. The way I use, because it was how I learned it way back in high school, is this German kid's name called Han Fickelbrei. And my chemistry teacher had this story about this young German boy who grew up in the winter. They'd skate on the rivers to get around, and it's Hans Bringer Andersen was his model for that, but he called him Han Fickelbrei. So to this day, that's still how I think of the diatomic 7, the Han Fickelbrei atoms or elemental diatomic molecules. So literally the name Han Fickelbrei tells you the 7. Now, another way is one that I didn't actually see and understand. I hadn't seen it before until I got to Hananiga. And one of the chemistry books that we used to use for ChemCom class, it introduced this method, and it's something I hadn't seen before. It basically used the idea that the diatomic molecules were the genuine molecules, the genuine elements, because anything that ends in gen or anything that ends in "-ine is going to be diatomic. So if you are genuine, then you are diatomic. So really, that's another way to do it. If it ends in "-ine" or ends in "-gen", it's going to be diatomic, and it works for all of the elements. And then the last one is the hydrogen 7. If you think hydrogen, go to element number 7 on the periodic table, which is nitrogen, and then you're going to draw a 7, NOF, and then straight down, ClBrI. Those form the number 7 when you connect the dots. So the hydrogen 7, hydrogen go to 7, make a 7, and those are your 7 diatomics. So really, those are 3 different methods you can have of remembering them, because really that's the only way to do it. There's no other way to know it's a diatomic except to know the 7 diatomics. Now, when we name them, it's actually fairly straightforward. Just like all the other atomic substances that are elemental, you're just going to give it the same name as the element. So just because it's a diatomic molecule doesn't mean we change its name at all, which is why oxygen was still oxygen, even though it's O2. So fluorine would be F2, oxygen would be O2, hydrogen would be N2, and H2, nitrogen would be N2, and so on. So the names of the diatomic 7 is really just the same name as the element was. So hydrogen is just an H2. So even though it's diatomic, keeps its elemental name. Now, how do you know if an element is an atom or a diatomic molecule? Well, you've got 2 different situations. Either you're looking at formulas or you're looking at names, and you have to know which is which. Well, first from the formula, we actually say in the formula when it's diatomic, we put a subscript 2. So if you see a subscript 2, you know you've got one of the 7 diatomics. If you don't see a subscript 2, then you know it's regular monatomic elemental substance. And then from the name, and this is the tricky one, the only way to know is to memorize them. You've got to know the 7 because there's nothing in the name that clues you in that nitrogen and oxygen are actually diatomic. Now, one of the things I want to mention, and this is going to become important, so I'll remind you again in the next set of notes when we get into molecules. Remember, what we're talking about here are elemental substances. When the substance we're looking at is just an element alone, not in a compound, then we ask ourselves whether it's diatomic or not. So that's always what we look at when it's elemental. When it's in a compound, diatomic is meaningless. So don't start putting 2s every time you see a hydrogen or an oxygen or a nitrogen, because that's only when they're alone we're talking about them being diatomic. So be careful of that. As we get into naming molecules, there's a different way to see how many atoms of a given nonmetal when it's in a molecular compound, a binary molecular compound. And that ends our first set of notes over the chapter.